Hi, everyone. Aaron Smith and Nancy Bakeman, and welcome to the EBA webinar podcast series. We're really excited. This is Module 5. If you're clicking through, you should have just come from one of the Windows series for your respective climate zone. And this is on insulation installation requirements and updates to the IECC on change compliance. In that document, we're really happy to have Joe Nebbia with us today. And as you can tell, I'm wearing a sweater, Nancy's wearing a jacket, Joe's got a flannel on. It's cold across North America. And what better time to talk about the new installation requirement updates than today? So Joe, welcome.
All right. Thank you, Aaron. Thank you, Nancy. It's a pleasure to be on again. I always love talking about the code and energy efficiency, and I'm always happy to partner with EBA in any way that I can. As Aaron mentioned, this is module 5 of an 8-module series on the energy code. So if you haven't seen the other modules so far, they're all available through EBA in recorded fashion. And then we do have a few upcoming as well, in case you want to catch the rest of them live. Today is on insulation installation. And the next few modules, next week we have air sealing requirements. Then following that, we'll have mechanical systems and lighting. And then the final module will be on alternative compliance paths, performance paths, and those sorts of things. So I'm excited to talk to you about this today. We do have a quiz at the end. Don't worry, it's not graded, but it does help us understand how well we're getting the information across. And for that, we're using a tool called Slido. This is only if you're participating in the live webinar, not the recording. Now, you can't click on the link, the slido.com there, but you can type that into a window in your browser, and there's a code for you to use there to sign into the quiz. I recommend starting to do that now so that it's ready. When I get to the slides that the quiz is on, it will automatically pop up in your browser if you've done that. Or you can use your phone and point it at that QR code, and it will take you on your phone to the quiz site. So you can do it there. You shouldn't have to log in or anything like that. It's a direct link to this quiz. And also, Aaron's going to post a direct link that you can click on in the chat. Again, this is only for our live participants. If you are watching the recording, you should be able to see us talk about the questions, but you won't be able to actually take the quiz. So again, I'm just going to give you a moment longer with this link up here to sign in. Either go to slido.com, type in the code, click on the link in the chat, or use your QR reader on your phone and get there that way. Also, please do stop me with questions. I know you can't talk on the webinar today, but type them into the Q&A or the chat, and Aaron or Nancy will stop me. I'm always happy to answer questions as we go through so that we can talk about what you are interested in, assuming it's relevant. So please do type those in as we go, and I'll try to get to as many questions as we can. So in previous modules, we've talked about the amount of insulation that the code requires. So R20 plus 5 would be R20 cavity insulation and R5 continuous insulation. That's an amount of insulation. But there is also quite a lot of the code that focuses on the installation of insulation. And this has been in the code for many cycles now. There are some important changes in the 2021 IECC that we'll discuss. But these details about how you install the insulation are going to have a big impact on the actual performance of the insulation. And I think one of the main things that I want to stress about this is if you're a builder and you're giving your home buyer a home that's been built to code according to the amounts of insulation you need, they've already paid the price for the amount of insulation. They've already bought the R20 and the R5 continuous, if that's what your local requirement is. But if you don't give them insulation that's installed correctly, they won't get the value out of that cost. The amount of insulation costs a certain amount. In some cases, it does cost more in time to do it correctly. I think in some cases, you'll see some of the details that get messed up commonly aren't really cost add-on things. They're just not doing it correctly. So think about that when we think about these code requirements. That's why they're there. It's because we can put R100 in our walls, but if it's not installed correctly, it's not going to work right. So that's an important part of the code. Now, as we talk about the code, there are requirements for if the insulation is in the cavity. So that's between the framing. So in a wall, if I've got, say, a 2x6 wall, there's insulation between each 2x6 member that's insulating that wall. Or there's also, well, I thought I had continuous there, but I guess I don't. I'll get to continuous. There's also continuous insulation, which is to the exterior. I think I have a slide later on that. Another thing that's important as we talk about code requirements for installation of insulation is that 2009 to 2018 IECC, which is what many of you probably have some version, amended or not, in your jurisdiction, talk about installation details as either prescriptive or mandatory. So if something was prescriptive, that meant that this was how you install it unless you're doing one of the performance paths, and then you have some flexibility around whether or not you follow this guidance or not. If it's mandatory in 2009 to 2018, then that installation detail had to be done. And there were things like the rim board must be insulated. That's a mandatory requirement. So I can't not insulate the rim board. It's just got to be insulated. But 2009 to 2018, there was some flexibility around how I do my basements, my slabs, whether or not I insulate the attic hatch, because those are prescriptive details. In 2021, the language changes a little bit. And for it, there's the prescriptive compliance option, which is similar to the prescriptive path in previous codes. And then there's just things that are required in all three compliance pathways: prescriptive, performance, or energy rating index. So the language changes a little bit. For the most part, the things that were mandatory in 2009 to 2018 are still required in all compliance paths, and some details that were prescriptive in the older code are now required by all three compliance paths. And so if you're in a jurisdiction that's changing from 2018 to 2021 or something like that, you're going to find that there was some amount of flexibility you had in those performance compliance paths that are now gone as far as installation details. And I'll talk about those as we get to them. Here's my slide on continuous insulation. It's supposed to be reversed there. Continuous insulation, according to the code, is insulation that's not interrupted by framing. So the idea, in most cases, it is an exterior insulation, rigid foam, something like that, that's installed on the exterior face of the studs and provides that continuous level of insulation that's uninterrupted by framing. There are some continuous insulations that are a little bit different, like an ICF wall actually has two layers of continuous insulation, one exterior and one interior. But for the most part, continuous insulation is usually exterior in nature. Something to keep in mind that doesn't fit into prescriptive or mandatory language that I just talked about is there is a general requirement in the code in R303.2 in the 2021 IECC, but it's been in the code for some time, that all insulation has to be installed per the manufacturer's instructions. So this is kind of a catch-all requirement, and it is in effect mandatory because it's not part of a specific compliance path, it's just code compliance. And it actually includes quite a lot of detail if you look at some of these manufacturers and what they have. And I have just a few kind of excerpts from different manufacturers that are out there and what they require. There's language like do not compress for fiberglass or mineral wool or something like that. There's language that says no support needed if the cavity is filled. So, sometimes I get asked things like, well, does the cavity have to be filled according to code? Well, the manufacturer says you have to fill the cavity, then you do. No gaps or voids, things like that is sometimes in the manufacturer's installation instructions. Cut to fit around plumbing and wiring. Some of this stuff is actually echoed later in the code as well. Trim to fill spaces neatly, fluff to full thickness. If this is in your installation instructions, then technically it's required by code. So that's something to keep in mind as we go through this, that just because the code has a list of things to look for, but you also need to look at those installation instructions because they're all adopted into the code because that's what the manufacturer says. So why do they say something like do not compress? This chart is kind of a visualization of that. If we look at, say, 1, 2, 3, the third row down, we see some 2x6 framing there. The one that doesn't have metal by it is wood. And a typical 2x6 wall is actually 5.5 inches, right? Anybody who's done any framing knows this, not actually 6 inches. If I put a R19 bat, so we go over to the column for R19 and find that 2x6 framing, I may only be getting an R18 actual insulation out of that bat, because for the most part, R19 bats are 6 1/4 to 6 3/4 inches thick. And the reason for that is they were actually designed as an attic insulation. They're not really meant for walls. And it started being put into walls because that was what was available. There are R21 bats out there. So there is a code compliant 2x6 solution that doesn't need to be compressed to get into a 2x6 wall because it's actually 5.5 inches. And they're a much denser bat if they're fiberglass to get to R21 in that 2x6. But people still put R19 in 2x6 walls quite a bit, and it's being compressed. It's really not being installed as it's meant to be installed, and you're getting less R value out of it because when you have something like fiberglass, the air pockets in that material are an important part of the insulating factor. And when you compress the insulation, those disappear. And so you get less R value out of it. If you're at a bat that's 6 3/4 inch, you might be down to an R17 when it's compressed into a 2x6 wall. So something to keep in mind for your installation. The material does matter, and where you're putting it is going to matter. No gaps or voids. Again, this is in a lot of manufacturers' instructions. So anytime when you've got a incomplete assembly where the insulation install is incomplete, this is something that could fail the house from a energy code compliance point of view, and the inspector is going to say, no, you have to remedy that before I can pass it. And it might just be one building cavity where that's the case, but it's not code compliant. On the left, on the left and right, we have some issues with spray foam not being done correctly. In the center there is a rim board in a crawl space where there was a duct register in front of that space, and it just got missed. But there we have an uninsulated rim board. It's a mandatory requirement in the code, and that could fail the house right there. Again, we don't want to compress because it affects the level of insulation. On the left there, we have things that weren't cut to fit around the plumbing and wiring, and that's not then going to be performing at optimal level. And even though cutting the insulation and cutting around that pipe is removing some insulation, really, it's going to perform better than if we compress it, and that compression is going to go beyond that the pipe itself. So we're going to lose a lot of R value in that wall. On the right, you'll see a picture where this is a friction fit bat. So friction fit bat doesn't have the tabs on the side. It's just very slightly wider than the cavity width, and it's installed, and it just kind of holds itself there. But unfortunately, in this case, they actually didn't cut them to the right length or height. So they've got a bat that's too big for the cavity, and it's just been crammed in. And because of that, it's not going to perform it at R21. So in this case, the homeowner paid for R21, but they weren't going to get R21 out of that installation. And fortunately, in this case, it was corrected before the drywall went up. But this is really, I don't know, R15, R13, something like that in actual performance because of the significant compression that's happened with this bat. And again, this isn't something that costs more to cut it to the right size. In fact, you're using more material on the right there than you really would need to comply with the code. This is a picture of an attic hatch. The code does say that the attic hatch should be insulated to the surrounding level of insulation. So if you've got an R49 attic, that attic hatch should be insulated to R49. If it's R38 or R60, depending on your climate zone, it should be insulated to that level according to code. This was a prescriptive requirement in 2009 to 2018. So you could do a little bit of trading if you were in the performance path around this detail. And you still could use a UA or something like that, a whole building U value comparison, if you're willing to go to that detail. I think this is an area where there's quite a bit of non-compliance with the code. I very rarely see these hatches insulated to R49 or something like that. It's usually much less, but that's what the code says. In 2021, this becomes a required detail. So it's no longer listed as prescriptive. It's called out in all three compliance pads that attic hatch is supposed to be insulated, and there should be blocking around the attic hatch in order to keep any loose fill insulation, if you've used loose fill, from falling in. There is some flexibility that's added in 2021 if you have drop-down stairs. So for drop-down stairs, this was always kind of a question you'd get when you talk about, okay, I've got to insulate the attic hatch, but what about the drop-down stairs? How am I going to get R49 on that? So the 2021 IECC does have a new solution for drop-down stairs, and that is that the hatch U factor has to be a 0.10, which is roughly equivalent, if you're assuming no framing, to that R10, and they want you to have an average value of an R10 insulation. Also, they have a requirement that 75% of the hatch have an R13. So in reality, most people are going to find a way to get this drop-down stair to an R13. And that could be done in a number of different ways. You could get an insulated product that could get to an R10 or R13, somewhere in that level as far as the actual stair assembly. And sometimes what happens is they put a box, somebody will build a box around this. You drop down the stairs and you kind of lift the box off, an insulated box. So you no longer have to insulate the drop down stairs to an R49 or R60 as you would in 2021 code to match the attic insulation. You do still have to insulate that attic hatch to that level according to code. But the attic hatch, if it's drop down stairs, doesn't have to do that. Also, there's some detail in 2021 that says if it's a vertical hatch, so a knee wall entering an attic space, something like that, it only has to be insulated to the U value required for fenestration. So it's treated kind of like a door in that case. Again, here we've got R19 insulation. So that's more than you would need according to the 2021 R13 requirement, but it's really not covering the whole stair assembly. So you've got some issues where it's not going to be insulated, and that's a significantly compressed R19, so it's really not giving you that amount. Eave baffles, wind baffles in the eaves are required by code if you have air permeable insulation in the attic. So air permeable insulation, air will move through it. Things like fiberglass, mineral wool, cellulose are all air permeable to an extent. And the idea is you don't want wind blowing up into that attic if you have a vented attic through the eaves and blowing through that air permeable insulation and causing a thermal issue at the ceiling. So if you have air permeable insulation in your attic, you have to have wind baffles. Again, this is something that was labeled prescriptive in 2009 to 2018. It's required in all 3 compliance paths in 2021. It doesn't have to be cardboard like shown here. There's some plastic products as well, but some sort of wind baffle has to be there if it's a vented attic. Bats have to be cut to fit around narrow cavities. This is something that's, or cut to fit in narrow cavities. This is something that's mandatory in 2018 and earlier. It's required in all compliance paths in 2021. Again, we don't want to take a wider bat and cram it into a space that's going to lose all of its insulating capability. There is a little new detail in 2021, and that is if the narrow cavity is less than an inch, it can be, it doesn't have to be insulated. It instead has to be air sealed, so caulked or foamed if it's less than an inch wide and can't be insulated. So it's treated almost like the jam around a window or door. It might 1 inch is a big window jam maybe, but that's what it's going to be treated like. So you're going to caulk it or foam it instead of trying to fit insulation. And if you're foaming it, you are insulating it in a way. But that's a new detail that's added in 2021. Again, it's mandatory that it's cut to fit narrow cavities unless that cavity is less than an inch. In 2021, we can now just air seal that cavity. And it's kind of recognizing that you're limited in your insulation choices for a cavity that's less than an inch. Has to be cut to fit around plumbing and wiring. I mentioned that on the slide before. Again, you can see here on the right how much compression happens. It's more than just at the spot of the box. If we were to cut that insulation, we lose a little bit of insulation, but we then are able to get full insulation all around the box. That's a mandatory requirement, 2018 and earlier. It's required in all 3 compliance paths in 2021. Cut to fit around plumbing and wiring. So if I've got a pipe like this, I need to be cutting to fit. And it looks like they did actually attempt to cut it, but it's still compressed. It wasn't cut neatly. So that's an issue there. Insulation around plumbing and wiring. This is a new detail in 2021 in all 3 compliance paths. Has to fill the space. This doesn't mean compress. So this insulation here is filling the space, but that's not what the code means when it says fill the space. It means fill the space around the plumbing or the wiring, but in an uncompressed way. Or insulation has to be installed to the exterior along with the air barriers. So thermal and air barrier are to the exterior of that plumbing and wiring. So an example of this might be an entirely continuous insulation approach. Maybe I've got R15 or R20 all to the exterior of the building and nothing in the cavity. And then I'm not really worried about cutting to fit around my plumbing and wiring. Any penetrations in and out of the building envelope, we have to, in 2021, there's some new detail added. This is true before, but now it explicitly says it, where the code says we have to insulate around the penetrations, again, tightly fitting, but not compressing. So I don't have a penetration here, but if something was exiting, like maybe a duct or a damper, exhaust duct or something like that, I would need to have my insulation tight around that to meet this requirement without compressing. Exterior walls behind showers and tubs must be insulated. This is mandatory. So historically, this has been a sequencing problem where the tub gets put in before the insulation, and then there's no opportunity at that point to insulate behind it. We don't want to have a cold wall behind our tub or shower on an exterior wall, so we have to insulate behind it. Again, that's mandatory in 2018 and earlier, all 3 compliance paths in 2021. Insulated corners, all corners must be insulated. So there really isn't an ability to use the old method of kind of a 3-stud corner that was empty, or a solid corner that was just all wood and not insulated. The corner has to be insulated. I have a few examples here. On the left, there's a furring strip that's been used. You could use a drywall clip, something like that, to essentially create this corner cavity with just a 2-stud corner. In the middle, there's actually still a 3-stud corner that's being used, but it's got rigid foam, in this case, in that cavity itself. But that cavity does need to be insulated. It doesn't say in the code how much insulation, it's just got to be filled with insulation. Here's an example on the left where they've done a corner that can't be insulated, that wouldn't be compliant. On the right, again, there's kind of an odd corner there. It's not a square corner, but it still can't be insulated. And so we've got an uninsulated corner. It's a mandatory requirement, and that home would not comply with the energy code. Headers also have to be insulated. So, on the left here, we have a header that could be single or double, and the header cavity is filled with insulation with whatever space is left. In the middle, we've got more of a manufactured header product with rigid foam in the middle, and on the right there, you can see a header with the cavity filled with rigid foam. So that header cavity does have to be insulated. It's mandatory. And in 2021, it's required in all 3 compliance paths. Here's another few pictures. This is on the left, an example of an insulated header. Again, not a lot of insulation there. So it's whatever space is left has to be insulated. Certainly not an R20 in that cavity that you're going to get. Here, though, we have a SIP wall, and that header is just insulated to the same amount as the rest of the wall because of that type of construction. But that would count as a insulated header. Rim joists, we've talked about this a few times today already, have to be insulated. So on the left, we have a problem. On the right, we do have an insulated rim joist. So that does need to happen, and that's mandatory in 2018 and earlier. 2021, it's required in all compliance paths. There's also some additional detail in 2021 that says it has to be in permanent contact with the exterior rim board. So in this case here on the right, it is in permanent contact with the exterior rim board. I couldn't do something like put in a bat of insulation that wasn't actually installed against the rim board there with some means of keeping it there. It has to be in permanent contact. So it doesn't have to be spray foam. There's a lot of different products you could use, but it does have to be in permanent contact with the exterior rim board. And so that's something to keep in mind for your rim joists. For floors, there's actually 3 different options. It's mandatory, but there's 3 options within the mandatory allowance here. Floors, we're talking about floors over unconditioned space. So not floors over a conditioned basement or a conditioned crawl. It could be a floor over an unconditioned basement or crawl, floor over a garage, cantilevered floor, anything like that. our insulation has three options. It can be installed in permanent contact with the underside of the subfloor above. So that's not what's shown in this picture here. But if that insulation, instead of being installed at the bottom of the joist, was installed at the top in contact with the subfloor, that would be an option. The next option is, as is shown here, in permanent contact with the sheathing of the space below. So if you had a cantilevered balcony, something like that, or any cantilevered space in the house, that floor, the insulation could be installed against the sheathing of the space below, which is just air in that case. Or it can be continuous across the joist. And this isn't something I see very often, but that would be shown with that blue board there. That would, I'm assuming that's supposed to be rigid foam, and it's installed continuous across the joist, and you would want it, of course, separating conditioned space from unconditioned space. So that's an option for installing your floor insulation. Those three options: against the subfloor of the space above, against the sheathing of the space beneath, or continuous. On the left there, we've got some insulation that's fallen down. It was installed against the space above, but now it's fallen. On the right, there it is in permanent contact with the sheathing of the space above. There's some compression issues there, but it is at least meeting that one requirement, that it be in contact with the space above. For unvented crawl spaces, so this is vented crawl space, we insulate the floor of the space above, just like we would for an unconditioned basement or something. For a vented crawl space, that's conditioned space. So we move the insulation to the wall instead of the floor of the space above. So the walls are insulated, and it has to go to the floor plus 24 inches. So it can go 24 inches further down below grade, or it can go 24 inches in, or some combination of that. You could also do an exterior insulation on your crawl space and have it all exterior and go 24 inches down, something like that. So that's required for unvented crawl space insulation. There used to be this kind of weird thing in 2018 and earlier where the crawl space insulation requirements were kind of repeated in the prescriptive and mandatory sections. So most of it was mandatory anyway. It's now all required in all three compliance paths in 2021. A class 1 vapor retarder overlapped 6 inches and sealed at the seams is required, and that vapor retarder has to go extend up the wall 6 inches and up stem walls. So that is required, and that's to prevent any kind of moisture, hopefully, from getting into that sealed crawl space, which typically is going to have a dehumidifier as well, and it's going to be supplied with conditioned air. Some addition in 2021, as I mentioned, some of that prescriptive detail moved into the mandatory section, and it's required in all paths. Basement insulation is one of those things that was in the prescriptive section. It was marked as prescriptive 2018 and earlier. So if you didn't like what the code said there, and you're doing one of the performance paths, you could argue, I don't have to do that because it's just prescriptive. 2021 now points to these requirements in all three compliance paths. So it's essentially mandatory. And those details are: the basement wall, if it's a conditioned basement, has to be insulated from the top of the basement wall, either all the way to the floor or 10 feet below grade, whichever's less. So not a ton of basements are going to be more than 10 feet, which means most basements are going to be insulated all the way to the floor. So what you see on the right here, that would not be allowed according to code. That's something where you really wouldn't be able to leave it up off off the floor like that. If you have a cavity wall instead of a blanket insulation, then it would need to come down to the bottom plate of that cavity wall if you finished off the space. But that's not allowed according to code, leaving it up off the wall. People do that because they're concerned about moisture and flood problems happening and then it kind of migrating up through the insulation. If you've got moisture coming in at the wall, it's probably in that insulation anyway. But the code does not allow you to keep it up 6 inches or a foot like is commonly done in installation practice. A few other details. Again, it was formerly prescriptive. It's now required by all compliance paths, no actual additional details, just that it's mandatory now. Slab on grade insulation is another item that was formerly marked as prescriptive in the code. So the code tables have amounts of insulation and lengths. So it was either 2 or 4 feet, and it was an R5 or an R10 insulation that was required for slab edge insulation. And the formerly prescriptive detail, 2009 to 2018, it was still prescriptive, says that the insulation has to extend to the top of the slab edge, and then it has to extend the length in the table, which in many climate zones was 2 feet. More of them are now at the 4-foot level in 2021, but it would be 2 feet any direction. Up in the top left, you see it's just 2 feet continuous. In the middle there, you see where it's 2 feet. It's a combination of horizontal and vertical, but the insulation has actually created a thermal break there by coming to the top of the slab edge. On the right, it's kind of going down and out, again, coming to the top of the slab edge. There's kind of a floating type approach down bottom left. And you can, in fact, according to code, if you don't want your slab just sitting on the foam, it does say you can cut the slab edge. As long as it comes to the top of the slab edge, you can cut that slab edge insulation at a 45-degree angle sloping away from the exterior wall. So that's allowed by code. Some people like that, some people don't, but it is an option. But again, this was prescriptive in 2018 and earlier, and a lot of people had trouble with slab edge insulation. It didn't quite fit what they were building, so they would go to one of the performance paths and trade off. They would just model this as an uninsulated slab and wouldn't need to do this detail. It's not an option anymore in 2021, but I will mention this about 2021 IECC. There's an error in the current printing, because in the performance path and the energy rating index path, they point back to the air sealing table, air sealing and insulation table as required. And that's where a lot of these details are found. And that table points to the basement, crawl space, and slab edge insulation sections as required. It's kind of how you get to this as a requirement. But that air sealing and insulation table in the current printing of 2021 accidentally references the crawl space section for the slab edge insulation. So it says slab edge insulation has to be installed per, and it points you to the crawl space section. Well, that's clearly an error. And in fact, it used to be the slab edge number and they just didn't move the number. That will be corrected, I'm assuming, in a future printing. But so that you don't have an issue with your code official, I would highly recommend considering slab edge insulation required in all compliance paths, because that detail was clearly meant to point to the slab edge insulation, even though it wasn't done correctly. So here's a couple of architectural sections on slab edge insulation. On the left, you have a continuous insulation approach where everything is to the exterior. And both of these are kind of monolithic pour slabs. So there's no break in the interior slab edge. So on the left, I've got an insulation that comes to the top of the slab edge. I create a thermal break because of that, because it's on the exterior and it would comply. On the right, this insulation really isn't doing anything in this picture. they've cut the 45-degree angle the wrong way according to code, but it doesn't matter because it's not coming to the top of the slab edge. And with this type of slab, it's not really possible. So this is an example of a builder who was doing this and still complying with code in previous versions of the code, because they would go to the performance path, model this as an uninsulated slab, which is what it is. And they would comply that way, because if I'm standing on this slab and it's cold outside like it is right now, and I've got my socks on, there's nothing insulating my body heat from leaving through that slab. And it has a direct thermal path across the slab and out. It's going to be conducted out. So this insulation, really, they shouldn't even put it in, because it's not actually performing any function. It's just costing money. So if the code requires slab edge insulation, it does need to come to the top of the slab edge in order to create that thermal break. And in 2021, this is not going to be allowed anymore. So on the right, you could still do performance path and comply. 2021, that detail is now no longer allowed. I mentioned the error in the table just to point out to you that you might read the table and see something different, but if you're trying to install your slab edge insulation according to the crawl space requirements, you're going to come into some trouble anyway. So keep that in mind. One thing we're going to talk about in the air barrier module next week is that the air barrier and the thermal barrier have to be continually aligned. And that's a mandatory requirement in the code. It's required in all 3 compliance paths in 2021. And the reason for that is they're meant to function together. If I've got my air barrier in one spot and my thermal barrier in another, I could have air moving through my air permeable insulation when I don't want it to be. In this example here, we've got a soffit, and the detail on the left here shows where I'm going to want to air seal so that my air barrier and my thermal barrier in the attic there is actually in alignment. If I were to air seal at the bottom edge, even if I have an interior air barrier, let's say I'm using my drywall and caulk and stuff on the inside as my air barrier, which is allowed by code, I couldn't do that on the bottom side of that soffit, even though I'm still following the path of the drywall, because the thermal barrier isn't there. The thermal barrier is actually on the other side of the soffit. And so that's important to make sure that I've got that air sealing there so that I don't end up with ineffective insulation or ineffective air sealing, because I don't have those 2 things together. Another example of this might be a cantilevered floor. If I've got fiberglass insulation and a cantilevered floor, and I'm standing on that floor and I've got no air barrier at the bottom of that floor, my feet are going to be cold because the wind's going to blow right through that air permeable insulation. Recessed lighting has to be airtight, and it must be insulation contact rated. So if you've got any recessed lighting pushing into a space that is insulated, like an attic, it has to be insulation contact rating, because it's going to come into contact with insulation there. That's a mandatory requirement, required in all 3 compliance paths. 2021 also says that those IC rated lights, insulation contact rated lights, have to be either buried or surrounded with insulation. You can't just keep the insulation back away from it. It has to come up to that light assembly. And that's why they're insulation contact rating, because they can be in contact there. So I don't know how many people interpreted the code as not requiring this before, but it's explicitly called out in the 2021 IECC. Those are all my slides for today. So start to think about any questions you'd like to submit. And now I'm going to activate the quiz and just have you answer some of these questions, and we'll go through the answers in case they didn't come through clearly. But we've got about 15 minutes left, and I'm happy to answer any questions that you submit. So the first question I've got, it should, if you've already logged into the Slido quiz, come up on your account. True or false, if I compress 3 R21 bats of insulation into a 2x6 cavity, I will achieve R63 wall insulation. Should be pretty easy based on what we just talked about, but I'll give you just a moment to answer and then we'll move on. Okay, false. Everybody got it correct. Happy to see that. If I'm compressing bat insulation, it's not adding R value, it's actually decreasing the R value. So that's important to remember. Next question, which are compliant options for insulating a wall if pipes or wires are present in the cavity? And there are a few different options that are correct answers here.
Joe, I think on that one, I can't select multiple.
Oh, well, sorry about that. I needed to check another box on the quiz. So there are multiple ones, right? And we'll see. Okay, so cut insulation to fit, use insulation that conforms to the space. That's correct. Very good. Install exterior insulation. All of those are the correct ones. I'm glad to see nobody picked one of the wrong ones. So yes, any of those work, and you should have been able to click more than one. I can't stuff more insulation to make up for it. That's not going to help. Can't squeeze it in behind. I can't wrap the plumbing in reflective insulation and leave the cavity empty. None of those are viable options. Okay, next question. Which is required by code? Thermal and air barrier must never touch. Air barrier must be to the interior of the thermal barrier. Thermal and air barrier must be continuously aligned, or the thermal barrier refers to the heating system and the air barrier refers to the air conditioning. Okay. Well, we didn't quite get that one right. I'm assuming somebody clicked the wrong item there, but no, the thermal barrier and the air barrier must be in continuous alignment. The air barrier doesn't have to be to the interior according to code. It could be a fully exterior air barrier. An example of that might be when you're using rigid foam as your air barrier and you've taped all the seams. House wrap can act as an air barrier. There's liquid applied air barriers that go on the exterior. Interior air barriers might be something like a aerosolized air barrier, although that is often an exterior air barrier because it's put in before the insulation, but as a retrofit, it could be done on the inside. But drywall and caulk on the interior can act as it, but the code doesn't actually require that.
So Joe, which one was correct there?
Thermal and air barrier must be in continuous alignment.
Got it. Okay. I got it right, but it marked it wrong.
Oh, you did get it right. Well, I've got all sorts of problems with my quiz today. So yes, you did get it right.
I thought, man, how did okay.
I just clicked the wrong answer as correct when I set it up. So
okay, it's a trick question.
It is, right.
Yeah.
Next question, what option is now allowed for narrow cavities in 2021 IECC? This is a new option. Okay, all right, I got this one right, and so did everybody else. If the cavity is less than 1 inch, it can be air sealed and must be air sealed, it says, instead of insulated. Okay, what happens to a bat insulation if it's compressed? This should be pretty easy. Hopefully nobody's going to get this one wrong. Hopefully I didn't get it wrong in the quiz. That's right, it loses R value. And that is the end of our presentation. So we've come in a little bit less than an hour. Some of these run a little bit longer than an hour. I imagine the air sealing section next week will be the full hour because there's a lot of information there on air sealing. So I encourage you to take part in that. Do we have any questions that have come in?
We don't, Joe. We've got insulation experts.
All right. Well, that's great. So a lot of the code is stuff that, as I mentioned at the beginning, it's just things that are required. It's in the installation instructions already. We should be doing it this way. And they're meant to make sure that our insulation is actually going to function once we install it correctly in the wall. And it really is something that if the inspector has the time and takes the time, a lot of houses are going to fail because it's done incorrectly, and anything from compressions to voids to all sorts of other reasons can fail you. And the code doesn't reference ResNet grade 1, for example.
Right.
That's a standard we talk about a lot, but when you look at what's described, it's really ResNet grade 1.
Absolutely.
I mean, there's that grade 2 and 3 doesn't actually comply with the letter of the code. Right. So even though it doesn't reference that installation standard, really you would need to be at a grade 1 in order to actually comply with the energy code.
Right. We did have a question come up on copies of the presentation, and we can have a PDF in the IBA Academy where this recording will sit. We'll also have this up on YouTube and then on the podcast channel for those watching it in recording, but we can put a copy of the presentation up there. So if you go to iba.org and click on the education and the IBA Academy, you should be able to go there and download a copy of the current presentation.
Great. Yeah.
Great. Thanks, everyone. Joe, I'll look forward to seeing you. If you're joining us live, it'll be Friday, January the 14th at 1 p.m. Central Standard Time. If you're joining us in recording, we look forward to seeing you in the next module.
Okay. Thanks
Great.
a lot.
Thanks, everyone.